Good afternoon everyone, I am Mr. Ish. Thank you for joining me for this video. The Folium of Descartes, we are looking at its polar representation. There are two different polar representations. I'm showing you both in this video, starting with the easier one, then going to the slightly harder one. X cubed plus y cubed equals 3axy represents the Cartesian or the rectangular form of the Folium of Descartes, where a is a constant. Based on that constant, the representation of that folium changes. But in general, you're looking at a representation which is like this. There is a asymptote. You have a folium which develops like this, and then it continues in this direction. The a value right over here impacts the representation and the area of that loop. Anyhow, you have this asymptote and you have symmetry along this y equals x line. But what is the polar representation? If this right here is your Cartesian equation or your rectangular form, how can we convert this into a polar form of the folium? Let's look at it. Method number one. If you consider from a unit circle, x is always equal to r cosine theta and y is equal to r sine theta, because any point on a unit circle, when you draw it with regards to a right triangle, this point here at a given angle theta, it has a certain x and a y value, and these are the parametric equations using right triangle trigonometry, and these are the values we bring into play into our Cartesian equation. X equals r cosine theta, y equals r sine theta. Plug away right over here. I'm looking here at an r cosine theta cube, then I'm looking here at an r sine theta cube, and it's equal to 3 times a times r cosine theta times r sine theta. You just have to manipulate this to arrive at the polar form. And remember, there are two polar forms. I'm showing you one form right here. You open this up, you have an r cube cosine cube theta plus r cube sine cube theta is equal to 3a r square cosine theta sine theta. Now consider this r square. If you were to divide r square here and divide it over here, you have an r cube which you'll isolate, and you'll have a cosine cube theta plus sine cube theta divided by r square. This r square has been transferred over here, is equal to 3a cosine theta sine theta. That's what you have. Simplify the r square and the r cube. When you cancel them out with this, you have an r cosine cube theta plus sine cube theta, which you will push onto the other side, and that will give you your polar representation 1. When you solve for this r, because this cube has been cancelled out by an r square, then you have r is equal to this representation, 3a cosine theta sine theta divided by this cosine cube theta plus sine cube theta. This right here is one of the representations, is a polar representation. It will demonstrate the polar coordinates, which would give rise to the Folium of Descartes based on the angle theta. You can even represent it if you want like this. You see how I have r equals? You can even write r with respect to theta is equal to, and then you write the rest. Either way of representing it is fine. R equals or r with respect to theta. So the representation number 1 is right here before you using this Cartesian equation. Let's show you representation number 2, but that depends on starting with the Folium's parametric equations. If you look at any point on the Folium of Descartes, the point x comma y in terms of parametric equations are what you see right over here. That would be your x, that would be y, where t would be a certain parameter. And you can interplay t with a different parameter. It's just a representation here only. But these are your parametric equations. 3at over 1 plus t cube is equal to x. 3at squared divided by 1 plus t cube is equal to y. The only difference between these two is here you have a t to the power of 1, here you have a t square. But these are the parametric equations, and this is what you would use. What do you do with these parametric equations? If you have parametric equations, you want to convert them into a polar form, these are my parametric equations, you can do it by means of two different items. X square plus y square is equal to r square, and also tan theta is always equal to y over x. Your opposite or adjacent is equal to tan theta. These are your two methods and procedures you have to convert parametric equations into polar forms. But you know this from trigonometry, so let's bring them into play. If I know from a unit circle x square plus y square equals r square, then I know if I square this, I square this, I must square this, and I must square that, then their sum should equal r square, and you can square this and you can square this and equal to r square. I would have a 9a square t square plus 9a squared t to the power 4 divided by common denominator. Because they're common, you can just add the numerators. You have a 1 plus t cube whole square is equal to r square. Look here in the numerator and isolate your common terms. You have a common term here, 9a squared t squared, parentheses 1 plus t squared divided by 1 plus t cubed whole square is equal to r square. Now, how do we get rid of this parameter and bring everything into the form, your polar representation in regards to theta? Well, you can, and I already clued you all with regards to how to do it. Tan theta is equal to y over x. I have y, I have x. Don't look at the squares, look at the y and the x, the original parametric equation. Your y was 3at squared divided by 1 plus t cubed, and your x was 3at over 1 plus t cubed. When you do the fraction algebra, this cancels out, that cancels out, the 3a cancels out, the t cancels out with this. You only see that t is equal to tan theta. That's what it's equal to. Tan theta is equal to y over x. When you simplify it, the only thing which remains is a numerator t coming from this y parametric equation. Tan theta equals t. Now wherever I have a t, I bring a tan theta and I work with that. So I know t is equal to tan theta, and I substitute it here into this form. I'm looking here at a 9a squared tan squared theta, because where I have a t, I'm bringing a tan theta plus 1 plus tan squared theta divided by 1 plus tan cubed theta whole square. But this is all equal to r square. If I solve only for r, I'm doing the square root of everything. R is equal to the square root of this. But there's a trigonometric identity you can bring into play. 1 plus tan squared theta is equal to secant squared theta. And this right here is equal to secant squared theta. Now you have to square root everything. When you square root everything, you're looking here at a 3a tan theta secant theta divided by the square root of this square. The square and this root will cancel each other out. You have 1 plus tan cubed theta is equal to r. So this right here is your other polar form. This here was your original polar form. You have two forms. Form number 1 and form number 2. These are your polar representations of the folium. Form number 1, 3a cosine theta sine theta divided by cosine cube theta plus sine cube theta. Form number 2, r is equal to 3a tan theta secant theta divided by 1 plus tan cube theta. And those are your two representations. These are your polar forms of the Folium of Descartes. And that's it. Thank you for watching.